Hello everyone. Today I am going to say about the AVL tree construction. So here, why we have moved to the AVL tree means at the time of constructing binary search tree, we are facing the problem of height. So while constructing the tree in the binary search tree, there will be height problem because here there will be maximum height. To reduce this, we are going to use this AVL tree. In this AVL tree, we will find first thing is rotations. So how we need to rotate the nodes to the left side, left to right rotations and right left rotations are going to perform here. Based on the rotations only, we are going to construct in this AVL tree. So here another one more important thing is that it is this tree is the height balanced binary search tree. Height balanced binary search tree. So here binary search tree. Here we are going to having the balancing factor. So just balance factor. So how to find this balance factor means height of left subtree minus height of right subtree. So height of left subtree minus height of right subtree. So here this balancing factor height will be, that means this number will be in between minus 1, 0 and plus 1. So the height will be in between either minus 1 or 0 plus 1. So if it is 2, 3, then we need to perform the rotations and then we need to find this height balance in binary search tree. So to explain this balancing factor and how we are going to consider this AVL tree as a height balanced binary search tree, I will show you through one example here. So these are my elements: 70, 60, 50, 87, 40, 37, 11 and 9. So here first I need to construct this. For AVL tree means it is also same as binary search tree. Construction will be same like binary search tree, but for after construction we need to check balancing factor. So here step by step at the time of constructing the binary search tree only I am finding this balancing factor. So see, for 70 I have inserted that node, it will be like a root node. So now for this node only again 60. 60 is less than 70, so it will move to the left side. So now I will show how to find this balance for this only 60 and 70. See, this is on a left side, this is the right side. For all the leaf nodes, you need to consider it as a 0 as the height. For all the leaf nodes, for leaf node, the height will be 0. This is the height. So here I will write the heights. So the height will be 0. So this is the root. No, just consider for any root, any root or node, how we are going to consider balancing factor is height of left subtree minus height of right subtree. So here see here how many nodes I am having here in left side. Only one I am having, minus height of right subtree. So here in a right subtree I don't have any nodes. So what will happen? 1. So here what they have mentioned, the balancing factor will be either minus 1, 0 or plus 1. So here I am having plus 1. So it will be accepted. Now again what I am going to construct? 50 I am going to inserting here. How it will happen? 70 and then here 60. So here 50, it is less than 70. It will move here and it is also again less than 60. So again it will move to the left side. So again I am going to finding the balancing factor. See, this is the leaf node, it is a 0 only. Then after that it is a 1 node, it is having a left subtree as 1 and it doesn't have any right subtree, so it is minus 0 and the answer is 1. So here at that coming to the root, same I will do. And the left subtree, how many it is having? 2 nodes it is having, and right side it is 0. So now what had happened here? 2 came. So what we had discussed, our balancing factor should be either minus 1, 0 or plus 1. But here what had happened? I got the high balancing factor as 2. Now what we need to do? Here I need to perform the rotation. So if you consider these all are on the left side. So simply what I can do? I just rotate all of them to the right side. So you know that in a previous video I have explained how we need to rotate here. See, I am performing the right rotation. So I am performing here right rotation. What will happen? 60 moves to this place and 70 comes down. How it will be? 60, then 50 here, and then 70. Now check the balancing factor. See, these are the leaf nodes. It is 0, and for 70 it is 0. So 60 is a root. Just check for this. And left subtree it is one element is there, one node is there, and right subtree one node is there. 1 minus 1 it is 0. So our balancing factor is 0 is there. So it will accept our height balance and binary search tree property. So 50 I have inserted. Now again what is there? 87. So see here 60. 87 is greater than 60. So it will move to right side. So here 70 is there. So 87 is greater than 70. So I will write it here again 60. So here what I am doing is at the time of inserting every element I am finding its balancing factor. So here 87 I have inserted. Now again I will find the height for this. So for this balancing factor, for 87 it is a leaf node, it is 0. See here for 70 it doesn't have any left subtree, 0. And here right subtree is there, only 1 is there. That way it will comes like minus 1. So minus 1 will be accepted. So after that, see here 50 is, it is a leaf node, 0 it will be. So for 60, for left subtree it is 1 and right subtree 1, 2. So what will happen? Minus 1. So here minus 1 will be accepted. So in a balancing factor minus 1 is there, it will be accepted. So it is also correct. So now again what I am going to insert? 40. So 40 means what will happen? 60. Again 50 is there. 40 is less than again 50. So it will comes here. Here 70. So here 87. So just check the balancing factor. It is 0. Here and left subtree one element is there, one node is there, and right subtree 0. So it is 1. So here same 0 and left there is no nodes, 0 minus 1 node is there on right side, minus 1. Simply here how many are there? 2 nodes are there on left side and 2 nodes are there on right side. It is 0. So see here 1 0 0 minus 1 0. So it will perform the, it is a following the correct height balance tree. So again another element is that is 37. So see here 37 is less than 40. Now see, it is less than 60, it will move here. It is also less than 50, again it will move here. Again it is also less than 40. So here I will draw the tree. 60, 50 and 40, again 37. So here 70 and 87. So now I am finding the balancing factor. Here 0. For 40 what is there? And left subtree is there 1 and there is no right subtree, 0. It is 1. So for 50, 2 left subtrees is there, 40 and 30. And there are no right subtrees. So it is 2. So no need to find the balancing factor for the 60 because, so if you find also see here 1, 2, 3 left subtrees are there, 2 right subtrees are there. So 1. But what is happening here? I am getting the 2 as the balancing factor. So it won't follow the height balance tree. What I will do here? I will simply, what I have told, only for the 3 elements we can able to do the rotation. So for that I am going to performing the rotation for this 50, 40 and 37. These all are on the left side. So simply you can able to perform the right rotation. Simply if I perform the right rotation, what will happen? 60, only 40 will move here and 50 will come down and 37 will be on the left side only. 40, 37 it will be and 50. Again on this side 70 and 87. So what we understood, again find the balancing factor. It is 0. It is also 0. These are the leaf nodes. So here 87 also will come 0. So for this check here, 1 left subtree is there, 1 right subtree is there. It is 0. And for 60, you can take like this way also. 40 and 30, it will be 1 2. Otherwise a 40 or 37, sorry, 40 or 50, it will be like 2 nodes, or 40 or 37, it will be as like 2 nodes. 2 minus here 2 right subtrees are there, 0. So check here, 50 is greater than 40, so it is on the right side. So if you all check here also, 60 is greater than 40, no, it is on left side. So here 50, all the elements whatever greater than less than 60 are on left side, and greater than 60 are on right side. So here I have inserted 37 also. Till now our tree is balanced only, because balancing factor is 0, or it will like see, if you check here 0 minus 1, it is minus 1. So after that, last elements are there. One is 11. So I am going to inserting 11. How I need to insert the 11 means, see here, 60, again 40, 37 is there, and this side 50. 11 is less than again 37, so I am keeping it here. 70 and then 87. So what will happen? I am just checking the balancing factor. Here 0. For 37, left subtree is there. There is no right subtree, 1. For 50, 0. Here 1, 2. 2 left subtrees are there. Only 1 right subtree. It is 1. See here for this, 1, 2, 3. 3 left subtrees and 1, 2. 2 right subtrees. Sorry, it is a 1. Actually 1. See here for this 0, and here 0 minus 1 minus 1. So if you check here 1 it is. So everywhere all are satisfying the balancing factors. So this is also the height balanced tree. And at last another element is there. What is that? 9. So just check how we are going to inserting 9 here. So here how I need to insert 9? It is again less than this 60, 40, 37, 11, and it is less than, no? So I am inserting here. So what will happen? So this side same, 70 and 87 will be there. Now again I am going to finding the height balancing factor. See here 0, and here 1 left subtree is there, and there are no right subtrees, 1. Here what will happen? 2 left subtrees are there. There are no any right subtrees, 2. Now here only I will stop my balancing factor, because here I have got the 2. So what I need to do? I need to do the rotation. If I perform rotation, then only we will get the height balancing. See, for these 3 elements or 3 nodes, I am going to finding the rotation. Again same, I am performing the right rotation. How it will be? 60, 40, and what will happen? 11 will move here, 37 will comes down, and 9 is on the left side only. So it should be in a tree shape. And again 50 and 70 and then 87. So just now I will again find the rotation. So not rotations, balancing factor. 0, 0. These are the leaf nodes, no? These all are the leaf nodes. So for everywhere I will keep the 0. And here 1 left subtree is there, 1 right subtree is there, it is 0. So 1 is there, 1 here is there. So for this 2 left subtrees are there, 1 right subtree is there. So 1. So what will happen? For 60, 1, 2, 3. 3 right subtrees, left subtrees are there, only 2 right subtrees. So what will happen? 1 will come. So now for this 70, 0 minus 1, it is minus 1. So this is our height balanced binary search tree. So for this we will call it as a AVL tree. So in AVL tree, everywhere it will follows the balancing factor. At every node, it need to satisfy the balancing factor. It should be either 0, minus 1 or plus 1. If it the balance factor is in between these elements, then only we will call it as the AVL search tree. So if you have any doubts in this AVL tree, you can please comment on the comment section. Thanks for watching my video.